All right, today we are going to go a little bit old school. We're going to go to the 2001 HSC paper. Question 18 we're going to be focusing on. A 30 kg mass, which we have A over here, was fired from a cannon in a projectile motion. When the projectile was at its maximum height of 25 meters, its speed was that. An identical object, B, was attached to a mechanical arm and moved at a constant speed of 20 meters per second in a vertical half circle. So that's our circular motion there. The length of the arm was 25 meters. Okay, so question 1A. It says, calculate the force acting on an object at its maximum height, or object A at its maximum height. So this bit here. Now, if you recall with projectile motions, there are a couple of assumptions that we make. If it's the y component, okay, the only acceleration that's affecting it is the acceleration due to gravity. So 9.8 meters per second squared if you need. We also know that the x component, there is no wind resistance. And so there is zero acceleration there. So at this peak height here, there is no acceleration caused from the horizontal axes. Hence, there is no horizontal force. The only force we need to take into account is the weight force, which is the force pulling the object down that way. So that's mass times acceleration due to gravity. Acceleration due to gravity is going down. We're going to point that as the downwards negative direction. So it's 30 kgs times minus 9.8. The answer we get here is minus 2,000 or minus 294 newtons. Okay, easy done. The next question we have, calculate the time it would take object A to reach the ground from its maximum position. So the scenario we're focusing on here is still A. So saying from this point here, it's going to go all the way here. What time does it take for it to get down there? Now we know from projectile motion, the only thing that affects the time of the actual projectile moving is the y component. Only y component will affect the time. Okay, well, let's have a look. The displacement is 25 meters. If I look at a useful equation to solve this, I'm trying to find time. I know the displacement in the y direction is 25 meters. Okay? I know that acceleration due to gravity is minus 9.8 meters. You also know that because it's falling 25 meters, so it's from a maximum height falling down, displacement is also a negative value here. Okay, well, I think a good formula I can use is this one. AT squared. Now some of you might be thinking, but what is UY? Well, UY, if you recall, if a projectile is going up, 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 at this very peak here, its velocity is 0. Well, what's this 20 for? This 20 is for the horizontal component. Remember, the horizontal and the vertical components are independent of each other. So it doesn't really matter. It won't affect our trip time. So UY in this question is 0 meters per second. Okay, well, let's put this out. Let's substitute all our components in. That's going to be 0 minus 9.8 and t squared. So if I want to move everything over, it'd be 25 times 2 divided by 9.8 squared, and that'll be t. So the value I get is 2.258769757. Now that's quite a big number. If we have a look at what numbers to round off to, the smallest values we used are all in two sig figs. So two significant figures. So I'm going to round my final answer to two significant figures as well. It's going to be 2.3 seconds. That's how long it took for it to drop to the ground. All right, question C. Describe and compare the vertical forces acting on objects A and B at their maximum heights. Okay, so this is something that's quite unique to physics, but I'm going to do my comparison as a little table. So do this. I'm going to say object A, and I'm going to say object B. Okay. All right. This is just to sort of do my comparison. Now, obviously, both objects have mass. That's kind of given to you in the question already. Both objects have mass. Okay, identical cannonballs. So if they both have mass, they're going to both have gravitational weight force. Okay, oh, my G's following me. Okay, so this has gravitational force. This also has gravitational force. And maybe I'll do another little column, forces acting on object at peak height. All right, we know that for a projectile, that's the only thing that's acting on it, right? Because there is no horizontal force, there is no acceleration, it's a constant velocity. But if you look at our little pivot here, this little mass is connected to a pivot point here. So firstly, this has centripetal force into it, and that's partly due to the gravitational force, but also from the tension of the pivot point. And just so happens, if I drew the diagram, the gravitational weight force is going down, and also the tension force is also pulling it down towards the center of the pivot. So that's the other force that's acting on object B. Okay? So tension force maybe I'll just dot point them. So tension force pulling object B towards the pivot point. All right. So that's like our little comparison here. The last thing is probably just do a little description. Compare the vertical forces acting on the objects. Okay. So object A only has gravitational force acting in its vertical component at maximum height, whilst object B has gravitational force and tension force creating a circular path or circular motion. Let's just go with path instead of a parabolic motion like object A. Probably went a little bit over in terms of what descriptions I have to make, but you should try and be very clear that you outline the fact that object A only has the gravitational force on it, and object B has both the gravitational force and the tension force from the pivot pulling it down. And that's how you do the question.